highest common factor. This new topic is H.C.F and L.C.M. H.C.F means highest common factor. L.C.M is the lowest common multiple. So we can start with this. Let's do this question using the first technique. Remember, we treated factors and multiples. So let's use that in solving this question. So we have 2. Let's find the HCF of 2 and 5 first. Then we'll find the LCM. HCF of 2 and 5. Factors of 2, 1 and 2. And the factors of 5, 1 and 5. Because 2 times 1 is 2, then 5 times 1 is 5. No other two numbers can multiply themselves to give you any of these two values or any of these two numbers. So the highest common factor that they have is 1. They both have 1. So what is common in them is just 1. HCF of 2 and 5 is 1. The second question says find the HCF of 4 and 16, because we're working with HCF first, then we'll go to LCM. HCF of 4 and 16, 4. Factors of 4 are 1, 2, and 4. Because 1 times 4 will give you 4 and 2 times 2 will give you 4. No other number less than 4 can divide 4 or can be multiplied by any whole number and give you 4. Now for 16, we have it as 1 times 16. Then you have 2 can go in 16, that's 2 times 8. Then 3 can go in 16, then you have 4. 4 times 4 is 16. So 4 can go in 16, 5 can go, 6 can go, and up the way until 8 and 16. So the factors of 16 are 1, 2, 4, 8, and 16. These are the factors of 16. Now, 4 and 16 in common have 1 as a common factor, they have 2 as a common factor, and they have 4 as a common factor. And you know the meaning of HCF means the highest common factor. The highest common factor. So the highest common factor is 4, because you have 2 and you have 1. But the greatest of these numbers is 4. So the HCF of 4 and 16 is 4. Method 2. Another technique of solving for the HCF of these two numbers is using the product of their prime factors. So we have 4. 2 can go in 4, 2. 2 in 2, 1. That's 4 equals 2 times 2. Then for 16, as we've done earlier, 2 in 16 is 8. 2 in 8 is 4. 2 in 4 is 2. And 2 in 2, this 2 in this 2 is 1. So 16 broken down to the product of its prime factors is 2 times 2 times 2 times 2. I know most people are used to this technique, so you pick what is common in both of them. 1 at the top, 1 at the bottom. So you can take 2 here, I can pick 2 here. I can also pick 2 here, I can also pick 2 here. So you have this as common and also this as common. We can now say the HCF is 2 times 2, which is 4. So also using this technique, you get that the HCF is also 4. Method 3. There's a third technique, and the third technique looks or seems less cumbersome and very easy, and it could be described as using the L.C.M style of solving to solve for the HCF. You can take it as 4 and 16, the two values. You have the first value as 4, the second value as 16. Now we have to divide them by prime numbers that can go in both of them. Even if you have 3 numbers, it's the prime number that can go in 3 of them that you're going to use. You know our prime numbers are 2, 3, 5, 7, 11, and so on. So we start with the first, 2. 2 can go in 4 and 2 can go in 16. You take 2. 2 in 4, or 4 divided by 2 is 2. 2 in 16 is 8. Looking at the two values we've gotten, 2 can still go in 2 of them. 2 divided by 2 is 1. 2 divided by 8 is 4. Now you have 1 and 4. None of the prime numbers can go in the two values. So that's the end. So we have our HCF as 2 times 2. So HCF is 2 times 2. 2 times 2 is 4. So using 3 methods, we got the same answer. This seems to be the easiest or the least stressful method of solving this question. So it's your choice to choose whichever you're comfortable with. But I still prefer this over the other two. So next is the HCF of 8 and 12. So we'll take 8 and 12 using the L.C.M style. So the first prime number that can go in 2 of them is 2. You have 8 divided by 2, that's 4. 12 divided by 2, that's 6. 2 can still go in 2 of them. 2 in 4, or 4 divided by 2 is 2. 2 in 6, or 6 divided by 2 is 3. At this point, there's no other prime number that can go in both of them. So we have our HCF, multiplication of the prime numbers that can divide both of them, which is 2 times 2, and our HCF is 4. So the HCF of 8 and 12 is also 4. Now the last question, the HCF of 9, 12, and 15. You rule your lines, then you have 9, 12, and 15. Now let's try 2, the first prime number. 2 can go in 9, 2 can go in 12, and 2 can go in 15, so you can't use 2. The next prime number is 3. We use 3. 3 in 9, or 9 divided by 3, is 3. 3 in 12, or 12 divided by 3, is 4. Then 3 in 15, or 15 divided by 3, is 5. So we can see 3 can go in the 3 of them. And on the next set of values, 3 can go in. Then the next prime number is 5. 5 can only go in 5. So therefore, there's no common prime number that can commonly divide the 3 of them. So the HCF of 9, 12, and 15 is just 3. Since 3 is the only number that can go in 3 of them,